Hey guys, today we're going to be in the new chapter, lesson 9-1, area of a parallelogram. So we got a lot of vocab. And today's date is, I'm going to put today's date, we're 4/20/2020. So, best to have this set of notes done by Tuesday, tomorrow, so that you know what I'm talking about, but we'll go over things. So let's talk about some vocab. First off, polygon. So this is our start polygon. Interesting. Polygon. This is going to be our intro to geometry. So we're going to be doing geometry for chapter 9 and 10, and then getting into stats on 11 and 12. Stats and graphs. So a polygon is a closed, means there's no openings, geometric figure formed by three or more straight lines. Now, because it's formed by straight lines, there's a geometric figure that you're probably familiar with that doesn't have any lines, it just has curves, right? So this means that it excludes circles. Circles are not considered polygons, okay? They're figures, geometric figure, but they're not a polygon, okay? And just to let you know, poly means, let's put it over here, poly means many, and gon means angles. So a polygon is one that has many angles, okay? All right, so the one that we're going to be talking about today is called a parallelogram. Now, you've actually studied a very common parallelogram in elementary school. Let's go with the definition, see if you can figure out. It's a quadrilateral and quad means four, and lateral means sides. So it's a four-sided figure. So think about your lateral latissimus dorsi kind of along the sides of your body. So I'm just going to put this guy's sides. Okay, we get a little Greek lesson today. So it's a quadrilateral, so it has to have four sides. So that eliminates a lot of other shapes. With both sets of opposite sides. Opposites. I try to do it all in one. Opposite sides are parallel to each other. Now, they can't all four be parallel to each other. That would not make sense, right? Okay. Now, kind of a fun thing that happens is we have opposite sides are the same length. Now that's a word, I think we've used this one before. I'm going to put it over here again. Is the word congruent. So if two things are the same length, have the same measurement, they are considered congruent. Okay, and that can be true about angles, that can be true about lengths of sides. All right, so let's draw a picture of this. Now, by the way, these notes should take about 1 page. If you take 2, that's fine. I'm going to have to take 2 screens just because of the way that my screen is structured. So this is a stereotypical looking parallelogram, and we have 2 major things we need to look for in a parallelogram. first is going to be a base. And so a base is usually what touches the bottom, okay? So if you have one base, its opposite would also be called a base. So it's just one side of the parallelogram. So again, when we're picking a base, we're just usually picking the guy that's on the bottom. Parallelogram. Such a long word. And yeah, so now remember how I said that the opposite sides are parallel? So in geometry, we can use this little triangle to let you know that those two sides are parallel to each other, okay? But remember we talked about that both sets of opposite sides are parallel? Okay, so both sets. So this side is parallel to the right side, the left and right. So notice I used two arrows and I did it in a different color. You didn't have to do a different color, you just needed to do the two arrows. So that tells you that the left and right side are parallel to each other, but they're not parallel to the top and the bottom, okay? And then we need one more piece of information in order to do area, which is what we're interested in, and that's going to be how tall is this parallelogram. So how we figure out how tall something is, we go from the highest point to the lowest point, but it's got to be perpendicular, okay? So this guy is called a height, and this little box right here means perpendicular to the base in this case, and that means a 90-degree angle. Okay? All right, now I can also come up with another height if I extend the line that contains the base, and I can drop from the topmost point perpendicular. He's also called a height. So sometimes you'll see the height drawn in a parallelogram inside the parallelogram, and sometimes you're going to see it outside. So I'm going to write down definition of height over here. It's a distance, or let's say I like the word the distance from the top corner. I like to do a corner, could be anywhere along that top base, top corner of a shape, or let's say figure. I like figure better. Of a figure that is perpendicular to the base of the figure. Okay, and did I want to add anything to that? No, oh, I do. I remember what I wanted to add. It's how tall is it? Is the figure. That's basically what height is, okay? Let's see. I've got a couple other vocab words. I'll put one here and then we'll continue on to the next page. I have a shape that is a parallelogram, except for it's got special features, and that's a rhombus. So that's a rhombus is a parallelogram. With 4 congruent sides. Okay, and that's all the room I have on this page. So I'm going to go ahead and shift over to the next page. And let's see, let's talk about a perpendicular lines. I'm going to really hammer home this. So notice I didn't title this because for me I'm still on the first page, are two lines that intersect. And again, intersect just means to cross at a right angle. Okay, and then remember, we'll just draw a little picture of it. You can tell they're right angles. That's the right angle symbol. Okay. Now, I had mentioned there is a shape that we've talked about that is a quadrilateral. Both sets of opposite sides are parallel to each other, and opposite sides are the same length or congruent. So, and I said we have a parallelogram that you are very familiar with, and that's the guy that's called the rectangle. So rectangle is a parallelogram, right? Because it meets the conditions of the definition. Okay. All right. Now, last thing I want to add is this guy right here. Let's call him Mr. Formula. And a formula is an equation. So it's got something equals something. That shows a relationship. Between quantities. Now I'm going to give you a little hint that when I'm talking the word quantities, I am talking about numbers, variables, and operations, right? So that's the relationship, deals with all of those. And when I'm talking quantities, sometimes numbers are involved in formulas, sometimes they're not. Remember, you had the formula for the area of a rectangle was length times width, and there was no numbers involved. But variables are very, very readily seen in formulas. Okay, so guess what? We do have a formula for the area of a rectangle, parallelogram. And it does look similar to the area of a rectangle, except it uses slightly different variables. It says all area formulas start with a capital A, and we have B times H, and I use lowercase letters. So the B stands for base, so that's the bottom of the shape, and the H stands for the height, or how tall the shape is. Okay, now what if I did underneath, so you can see this area of a rectangle, and I'll draw a picture to show, is length times width. Okay, so let me show you again a picture of a parallelogram. So here's your B, and here's your H. Now, here's kind of funny thing, and I'd like you guys, oops, sorry about that, to try this with an index card. Okay, so a 3x5 index card. Draw a line from a top point, or actually just cut off any triangle end. Let's do that. Cut off any triangle end off of an index card. And then rearrange those two pieces into a parallelogram. So you're going to see that the rectangle is going to be the same. I'm going to see if I can figure out how to do it, or I'll do it tomorrow in our class. That's right, I'll do it tomorrow in our class. Okay, so with a rectangle, we have a length and a width, but notice that they're right angles. That's what rectangle means, right angles. So it's like I took this piece and put it over here. Okay, and then there's my rectangle. So there we go. All right, so the height is like the width, and the base is like the length. All right, so let's do a couple practice problems. Directions, we're going to do two different types of problems are going to show up. So we'll have two different sets of directions. So find the area of the parallelogram. And so I'm going to draw a picture of our parallelogram. Boom, 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 boom. And this is 17 meters. This is 4 meters. So this is an example when we've got a number being shown outside. He's 16 meters. So our formula says area equals base times height. So my job is to identify who's the base and who's the height. So let's get a different color here. That is your base. Okay, now remember the height is perpendicular to that base. Okay, so this is perpendicular to the base, so that's your height. Now, what's that 17? Well, it's the length of that other side. Okay, so we have bases that have 4 meters, and we have bases that are 17 meters. So why would I need to know, oops, yeah, let me go back to here. Why would I need to know this guy if I wanted to do the perimeter? And remember, perimeter is just the area, or the distance around the outside of the shape. So I'd have a 4 plus a 17 plus a 4 plus a 17, okay? All right, so let's go ahead and solve this problem. So I have A equals the base, which is 4, times the height, which is 16. So if you need to do the math off the side, but I've done this so many times, I know that 4 times 16 is 64. Now, I need to add a label. So let's go back and see what the labels were. Well, I had a meter times a meter. So how many times do meters show up? They show up twice. So the area is 64 square meters. So all area is in square meters. All area, doesn't matter what the shape is. Okay, let's try a different one. This is going to be kind of a mystery one. So find the missing dimension of the parallelogram. So let's get a picture going here of our parallelogram. And don't ask me why. I can't seem to draw my parallelogram slanting the other way. Yep, just my foible. So that guy's 9 inches. They tell me what the area is. That's strange. 45 square inches. And then we know we need to have a height. Okay? So I start always with the formula. Area equals B times H. But what's weird in this particular problem is that it tells me the area, right? And that 9 is the same on the top and the bottom, so that would be my base. So what's missing would be the height. So that's this guy over here would be considered the height. So we just have H because I don't know what he is, right? So we're just going to go ahead and substitute numbers in where they go. So A is the same as 45. And then we have equals, and B is the 9. And the height is going to be the H. So I'm going to rearrange this because I like to have my problems around the other direction. So I'm going to have 9H, like the variable on the left, you know me, equals 45. And so then the inverse of multiplying by 9 would be dividing by 9. So that's what I'm going to do to both sides. I'm going to divide by 9. Because I know 9 divided by 9 is 1, right? And I have 1 times H is H. So I get H equals, and 9 goes into 45 5 times. So then I would say the height is, now this is a dimension, So it's not going to have a square label, right? The square label is simply for area. So the height is 5 inches. Okay, so I'm just going to jot a little note here. Area squared, and then you can put inches, feet, miles, meters, and so on. And then a side length, or a side value, is just going to be inches, or feet, or miles, or meters, and so on and so forth. All right, there we go, guys. All right, see you on Tuesday.